And in this video I will simply show you humans adapted to breathing underwater. Is this possible? Of course. If you are new to the channel, subscribe and leave a like to stay up to date with everything that happens in the animal world. If you hold your breath and dip your face into a tub of water, your body will automatically trigger what's called the dive response. Your heart rate slows, your blood vessels constrict, and your spleen contracts. Reactions that help you conserve energy when you're low on oxygen. Most people can hold their breath underwater for a few seconds, some for a few minutes. But the Bijoux take free diving to the extreme, remaining submerged for up to 13 minutes at depths of around 60 meters. These nomads live in the waters surrounding the Philippines, Malaysia and Indonesia, where they dive to fish or collect natural elements used in crafts. Now, a study published in the journal Cell reveals the first evidence that a DNA mutation that enlarged the spleen gives Bijoux a genetic advantage for living in the depths. The spleen is not among the most glamorous organs in the human body. You can technically live without it, but while you have it, the organ helps support your immune system and recycle red blood cells. Previous work has shown that in seals, marine mammals that spend much of their lives underwater, spleens are disproportionately large. Study author Melissa Lardo of the Center for Geogenetics at the University of Copenhagen wanted to see if the same trait was true for human divers. During a trip to Thailand, she heard about the sea nomads, and was impressed by their legendary skills. I wanted to get to know the community first, and not just show up with scientific equipment and leave, she says of her initial trips to Indonesia. On the second visit, I brought a portable ultrasound machine and spit collection kits. We went to different houses and took images of their spleens. I had an audience, she adds. They were surprised that I had heard of them. She also collected data from another group of people, the Saluan, who live on the Indonesian mainland. Comparing the two samples in Copenhagen, the team found that the average size of a Bijoux person's spleen was 50% larger than the same organ from a Saluan individual. If there is something happening at the genetic level, it should be noticeable in the size of the spleen. And there we observe this extremely significant difference, she says. The researchers also came across a gene called PD10A, which is thought to control a thyroid hormone in the Bijoux but not in the Saluan. In mice, the hormone is associated with spleen size, and mice that are engineered to have smaller amounts of the hormone have smaller spleens. Lardo theorizes that over time, natural selection would have helped the Bijoux, who lived in the region for 1,000 years, develop genetic advantage under pressure. While the spleen may partially explain how the Bijoux dives so well, other adaptations may be at play as well, says Richard Moon of the Duke University School of Medicine. Moon studies how the human body responds to high altitudes and extreme depths. When a human dives deeper into the water, the increased pressure causes the blood vessels in the lung to fill with more blood. In extreme cases, vessels can rupture, causing death. In addition to genetically inherited adaptations, regular training could help avoid this effect. The chest wall of the lung can become more compliant. There may be some looseness that develops during training. The diaphragm could become stretched. The abdomen may become more compliant. We don't really know if these things happen, he says. The spleen is capable of contracting to a certain extent, but we don't know of any direct connection between the thyroid and the spleen. Could have. Cynthia Beale is an anthropologist at Case Western Reserve University and has studied people who live at very high altitudes, including Tibetans who say they live on the roof of the world. She thinks Lardo's study opens up interesting research opportunities, but needs to see more measurable biological evidence before she can be convinced that a genetic trait is helping the Bijoux become better divers. You could do more measurements on the spleen. For example, measure strength of its contractions. She says, "What can we see at sea?" In addition to understanding how the Bijoux became good divers, Lardo says the findings have medical implications. The diving response is similar to a medical condition called acute hypoxia, in which humans experience a rapid loss of oxygen. The condition frequently causes death in emergency rooms. Studying the Bijoux could effectively serve as a new laboratory for understanding hypoxia. However, the nomadic sea lifestyle is increasingly under threat. They are considered marginalized groups and do not enjoy the same citizenship rights as their mainland counterparts. The increase in industrial fishing is also making it difficult for local stocks to survive. As a result, many choose to leave the sea. Without support for their ancient lifestyle, Lardo fears that the Bijoux and the lessons they can impart on human health may not last much longer.